This lesson we're going to go in a little deeper with the normal distributions, and we're going to look at the standard score, or otherwise is the z-score, right? So your z-score is theta value minus mean over standard deviations. That's how you're going to find z-score. Let's look at example 1. It say the score of the standardization test for normally distribute with the mean of 510 and the standard deviation of 95. This is same problem as the one that we were looking at it in the normal distributions. The first question is asking a student scored 365 points on the test. What is his standard score? So what they're asking you to do is, in that normal distributions with mean 510, standard deviation of 95, the student score somewhere 365, and they wanted to know what will be the standard score of this point, right? What do we do? Well, we are going to use the formulas. So we will do theta value minus mean over the standard deviations. And this gives you negative 145 divided by 95, which is close to negative 1.53. And it is negative because it's on the left side of your mean, right? If it was the right side, it's going to be positive. So you could say negative 1.53 means that 1.53 standard deviation below the mean, right? That's what you could say. Second one is asking what test score corresponds to the student's score of 2.2. So this is going the other way around, right? So B, this is going to be your z-score, standard score. So if z-score is 2.2, you wanted to find out what actual test score was, right? So what you're going to do is you're going to do actual test score is going to be 2.2 times 95 and plus 510. So actually you're going backward. Or if you wanted to replace it in this formula, you could say z-score is 2.2. You are trying to figure out actual score minus 501 over 95, right? You should be able to do that. Just plug into the formula. In order to solve x, let's try to get rid of fraction first. So you're going to multiply by 95. And then get rid of minus 510 by adding both sides by 510. 510, right? This gives you x equals to 95 times 2.2 plus 510. And that's same as this one, right? And you're going to get 719. So test score of 719 corresponds to a standard score of 2.2. That's what we can figure it out from example 1 using the z-score formula. So we're going to try one more problem just like that. So this one is asking the weight of the certain dog breeds are approximately normally distributed. So we need to make sure this given information is normally distributed in order to use the normal distributions with Z-score. With a mean of 62 pounds, standard deviation of 6. The first question is asking a dog of this breed weighed 55 pounds. What is the Z-score of the dog weight? Is this dog weight usual for this breed? So let's do one at a time. So we wanted to see if we can find Z-score, right? With 55 pounds. So we use the formula. We will say the Z-score is the data minus mean over standard deviation. That's negative 7/6, which is negative 1.17. So this means that 1.17 below the mean, right? Because it was the negative. So we'll be on the left side. The next question was, is this dog's weight usual for this breed, right? Well, because this is within the 1 standard deviations, within the 3 standard deviations, yes, you could say this is going to be usual. What about, that was A, what about B? It say the dog's weight has a Z-score of negative 3.2. What is the dog's weight, right? So if we replace this, we're trying to find the weight. So the Z-score was negative 3.2. We're trying to find actual weight minus 62/6. So in order to solve this x, you're going to multiply both sides by 6 first. Gives you, this is multiply, right? So then you're going to get negative 19.2. And in order to isolate x by itself, you're going to add 62 both sides. So that will be your x value, negative 19.2 plus 62. So this is going to be 42.8 pounds. So if dog's Z-score is negative 3.2, actual weight is going to be 42.8 pounds. Example 3. The lengths of mature trout in a local lake are approximately normally distributed. Again, normally distributed is important. With a mean of, your mean is given, standard deviation of 1.8. Make sure you have 1.8 inches. So the first, they're asking you to draw the normal distribution curve with the given informations, right? So you have normal distributions. Your mean is going to be 13.2. And because your standard deviation is 1.8, this is going to be adding 1.8, which is 15. 1.8 adding will be 16.8. 1.8 adding again will be 18.6. And this is going to be subtracting, so it will be 11.4, subtract 1.8 again, will give you 9.6. This is going to be 7.8. So that's going to be normal distribution curve with the given information about the trout, right? But then B is asking to draw the normal distribution curve and label standard normal distributions. So with that information, this is going to be 0, and this is standard deviation is 1, 2, and 3, and this is going to be -1, -2, and -3. And C is asking, find the z-score corresponding to a fish that is 19 inches long. So 19 inches is going to be somewhere here, right? And we wanted to find the z-score. So let's do that. Remember the formula, right? So it'll be 19 minus mean divided by standard deviations. This gives you 3.22. So that's how we can tell from the normal distribution with exact value, which is your 19 is right here. The same point, it will be your z-score, 3.22, right? Exactly same point, is just different value. What about D? How long is a fish that has a z-score of -0.85? So -0.85, that's going to be somewhere here. So I know that's going to be between 11.4 and 13.2, right? But we're going to do algebra, right? So the z-score is -0.85. You wanted to find actual weight. So your x should be -0.85 times 1.8 and plus 13.2. And that gives you -1.53 plus 13.2, which is 11.67 inches. And it makes sense because remember I said the value should be between 11.4 and 13.2, right? So we know that should be the right amount. What about E? Draw the z-score from part C on your graph from part B. We already did that, right? So it will be this, which is E. I have one more information about the normal distribution, which is finding a percentage with the normal distributions. That is going to be our next section lesson. So make sure to look for the finding a percentage from the normal distributions from my other videos.